Hello again, here from Santa Clara. We're live on Twitch. You know that already because you're watching us live on Twitch. But I'm Brandon from the AWS Evangelism team. We've got a couple awesome guests up here with me. We've got Alex and Kunal. Introduce yourselves.
Hello. Hey, so I'm Alex Pistavros. I'm a senior product manager in our Elastic Compute Cloud group within AWS. This is the group that effectively runs the infrastructure for AWS.
Hey guys, I'm Kunal Batra. I'm another senior technical evangelist at AWS.
Cool. So something new just launched for EC2. If you don't know what EC2 is, stay with us. We're going to cover a bunch of that. We'll get to it. Also, I want to call out right now that Alex is an EC2 expert. So if you have any questions at all about EC2, please post them in the Twitch chat, and we will make sure we get them asked live to Alex so that we can get you answers on all of your most pressing questions when it comes to compute. So what's the new stuff that launched, right? We've got some new instance types available now.
Yeah, so today we were able to launch a new variant of our AMD EPYC instance types. So if you go back, let me take you back to last year. We only had a single processor choice within EC2. So these are our Intel processors for EC2. A couple years back, we did launch a system called the Nitro system. And what these are the fundamental building blocks that we were able to provide as part of the server so that we can iterate and provide more and more options for our customers. So one of the things we did last year was engage with AMD, and we launched an AMD EPYC version of these servers, specifically in our general purpose and memory optimized instance types. So these are the M5s and R5 families, and then we denote the AMD portion of that with a little A subscript. Today what we did is we expanded that family and even added the high-speed local disks. So these are NVMe connected SSDs. These are intended for super low latency operations that you want to have the storage located within the server.
Cool, so all of that sounds really, really great, but I'm sure to a bunch of our viewers, they're like, I don't know what any of that means. So let's start from the very, very top here. Let's talk about EC2. One of the oldest, most fundamental services that's offered by AWS. What is it? It's generalized compute.
Yeah, it's compute. So when you think about running in the cloud, ultimately you just want to run a workload or do some operations, mathematical, or store data and then operate on them. You need a server or some kind of compute entity to do that. Within EC2, what we do is we offer virtualized portions of these servers, so you can go launch what we call instance types, or virtual machines with a select number of virtual compute units, amount of memory, it has networking, storage, so really all you need to start running and doing your workload in the cloud.
So instead of being me when I was 13 building a PC in my parents' basement, I basically now can go to the AWS console, configure some options, and then in the cloud there's a server ready to go for me to do whatever I need with.
It's exactly right. So we take away a lot of that old style rack and stack that people would have to do, or in this example, if you're going to go build and tinker a PC, that's what we get to do now, and we get to do that at huge scale across 20 regions and 61 availability zones all around the world. And then we have actually over 160 different instance types, and this has been enabled by that Nitro system. So we're iterating quickly, and instead of just offering, hey, I can give you one different processor type, or I can give you one configuration that has maybe not enough or too much memory, we're able to now customize those specific VMs for your workload. So now you're getting a lot more optimized. So if you think about how much money you spend, we have this big, you only spend and pay for what you use, and picking the right instance type is a big part of that. And that's what we do by bringing in something like AMD EPYC, we can offer lower prices. Bringing in high-speed storage, we give you the option if you're going to run your databases or do some kind of cache tier when you're operating your workload, you have that option now. And that's all incorporated within EC2. And then you just pay for a portion of that depending, or you can pay for the whole box depending on what you need for your workload.
Cool, so I'm really interested to talk more about Nitro, but we'll do that in a moment here. Okay. Since now we know about what an instance type is, how these all work, what EC2 does, what are the reasons that I would want to use these new AMD-based instance types compared to the traditional types that have been available?
So we see customers using these AMD instance types for a few reasons. The first one is it's lower cost. So these are going to be 10% lower cost than the equivalent current versions of these instance types. People, when they do use EC2, because it is that fundamental piece of their deployment in the cloud, it ends up being, usually for most customers, the largest portion of their bill. So if there is a way to reduce that without any impact to their performance, it's a win-win for everyone, right? So cost is one. The second thing is these are x86 compatible. These run the x86 64-bit instruction set. So between Intel and AMD, you have a lot of application compatibility. So that's great. So if you're running an application today in the cloud or on-prem and you want to use it on AMD or Intel, you have that flexibility. Third thing is we actually offer the same instance sizes or virtual machine sizes between Intel and AMD. So it makes it really easy for you to say, okay, let me try AMD, and if it works for my workload and I'm seeing the right performance characteristics that I want, I can stay there, or let me go switch to an Intel version for maybe something a little more compute heavy. So you have this flexibility between the two, and it makes the choice to do that very easy. And then the amount of work you have to do, because they are the same instruction set, is very little.
Cool, and you mentioned their x86 architecture.
Yeah.
I don't know if we want to get too deep into that, but I do just want to mention that we now also have ARM-based processors that you can use as part of EC2 as well.
That's correct. Yeah, I mean, when I was talking a little bit earlier about Nitro, and I think we'll dive into it a little more here, those building blocks, they are the fundamental pieces, the components, when you think about the hypervisor, the security, the networking, the storage, with either EBS or local storage, right? And then the component that we've been able to play a lot with in the last couple months has been the processor. So bringing in AMD, which gives you that compatibility on x86, which is an instruction set that AMD and Intel share. And then we are actually able to build our homegrown AWS Graviton processor, and this is based off the ARM instruction set. So that gives you another vector of optimization that you can do. The ARM ones specifically, we target those for really cloud optimized workloads that are scale out. So those have been really successful in those types of scenarios.
And I really love that because we have custom designed silicon now that you can spin up on EC2, which is really, really cool. All right, so there's a couple questions from Twitch. We have one that I think is a good question, and this is asked by Bob with way too many B's in it. But so really, what is the downside for somebody not very knowledgeable about hardware for using the AMD EPYC-based instances? If they're 10% lower costs, I think you mentioned briefly that for like very intensive compute, Intel instances might be better suited. But if you don't really care about hardware, what's the downside here?
I don't think there is a downside, to be honest. I think the way I think about it is, one, we're just trying to give customers more choices. We've done this by giving you different sizes, right? The whole advent of virtualized technology gives you different instance sizes. So you can have as small as 2 vCPUs all the way up to 96. Now we're saying, hey, if you want to use a different processor, you have that option. So what we see a lot of customers do now is usually start with the lower cost option, like an AMD, right? And because we put them in the M5 and R5 families, these are very common families. We call these like the core products or the core instances. These are the ones you'll typically start with when you get to the cloud, right? These are the ones you'll run your web servers on, you'll run your dev and test environments on. Like super easy decisions, go try them. So you start with the AMD, it's a lower cost point. And then what we've seen is customers who are really focused on pushing every ounce of compute and are really, really pushing the limits on maybe some kind of inference or some kind of really compute-intensive workload, then they can go and use the Intel ones to optimize. So now we have this kind of two-tiered approach, so we can save customers money, especially during the dev and test phase or the initial migration phase. And then as they deploy, they can deploy on either Intel, AMD, and now ARM as well.
Cool. So I think that's also one of the great things about EC2, right? You can move between these different architectures relatively easily. It's pretty easy to shut an instance down, spin up a new one on a different type, have everything copied over, especially if you're using S3 for object storage, right? All your data is still going to be available. You can mount it as a disk. It's super easy. So I think that's a great approach, right? Use the cheap option until you have a good reason not to.
Yeah, and I'll just add to that. Like we see a lot of customers actually using our ECS or Elastic Container Service or EKS, right? Underneath that, you have the option to actually pick the infrastructure. And what customers tell us they really care about is not so much like I need every ounce of performance of every vCPU or a certain memory performance that they're going for, but what they really cared about was a consistency of performance as their number of containers would scale, right? And you can accomplish that very easily with these new AMD types, and that's one area where we've seen a lot of traction.
I have a Twitch question over here.
Yeah.
What are some non-mobile use cases that benefit from using an ARM processor?
What's a non-what, sorry?
A non-mobile use case?
Oh, mobile.
Yeah.
So with ARM, we actually have quite a bit of web tier workloads. So if you think about ARM as an architecture, a lot of people don't know, but a lot of things like Java, for example, could run on ARM just as good as it runs on x86. So we see a lot of customers that want to do their web tier. It can easily be done with an ARM. And the way we've implemented it, there's actually a pretty strong cost advantage of using ARM. So using that for something like a web tier where you are doing a large scale out is a really good option.
Yeah. Cool.
Yeah, if I remember right from the launch announcement of reInvent, it's like 40% cheaper
Yeah,
ARM compared to x86.
It can be up to 40%
I guess now it'd be 30 if you're using the AMD instance types. Did I do my math right? I'm not sure I did.
No, but I think just to elaborate a little more on the ARM, if you think about, even in Werner's talk today, right, he talked about kind of reinventing the database for the cloud. I mean, that's the kind of approach that we're taking, right? You know, we've done a lot of innovation within EC2, and I think we're trying to take that further and further as we learn things that could be a little more cloud native and more optimized for that cloud scenario, which is how we get some of those cost savings as we iterate generation over generation. Yeah.
So, you may not know this, but I'm going to ask it anyway. How many different instance types are there now?
Right now, there's over 160.
Wow.
So yeah, so there's a lot, but the good thing is they're all very purpose-built now, right? So it can sound a little bit intimidating, but really the ones you want to care about if you're just getting started or just trying to learn about the cloud are the M5 families, right? The M5 is our general purpose. It gets you started in the cloud, and we have AMD version, an Intel version, and both of those with storage. So you can, just within the M5 family, you have 4 different variants. We have our C family. These are really optimized for heavy compute. And within the C family, we have another version that has 100 gig networking, which is optimized for HPC. And then the R family, which is our memory optimized. So this one will have the most memory, really pushing down the dollar per gigabyte you would need to run more like in-memory databases or situations where you want to do a lot of operations in the memory. You'll need a little bit more. The R is a great choice. So between C, M, and R, there's a lot of variants. It can get a little confusing, but that's where you'd really want to start and investigate, because we see most customer workloads will end up on one of those 3.
Okay, that makes sense.
Nice.
I think part of the explosion in the availability of the different types of instances relates back to what you mentioned earlier, which is Nitro.
Yeah.
So let's talk about it. This is something that I don't really know anything about, so I'm really excited to learn right now. But yeah, let's talk about what Nitro is and how it enables these new, quick, rapid deployments of instant types.
Yeah, absolutely. So there's a lot of really good content on some of the deeper technical portions of Nitro. If you go on YouTube, you can actually see a lot of videos from some of the actual engineers that developed and conceived the system, but I'll talk about it today from a little bit of a higher level and why it's relevant for this launch. So Nitro is really our name for the AWS system that can power the EC2 infrastructure. So this is the hypervisor. So the hypervisor is what gives you the opportunity to cut out all these different virtual machines on a hardware type, so that way you don't have to just buy a full server. We can sell you a portion of a server, right? With that comes a lot of security. So we have our own security implementation as part of the Nitro system. Then you need networking, right? That's how you get access to other instance types. It's how you get access to your customers that are coming in and out. So there's a networking component of that. And then what we've done with all these components is actually taken them off the main compute, which in this case is an AMD or an Intel, or even our Graviton, taking them off onto a Nitro card. So that way, when we do sell compute to customers within EC2, there's no overhead to run the services. So all the stuff that we're doing to manage security, manage virtualization, manage the storage, manage the configuration that you want to launch, all that has been offloaded onto our Nitro card. So all that technology together is what we call Nitro. So what that means is some of the components on the system, whether it's an ARM chip or an Intel chip, an AMD chip, It really becomes like a puzzle now. You just got to pick whatever configuration that your customers are telling you matters for their workloads, and then we can implement those and iterate very quickly, because that core component, the hard part of doing infrastructure in the cloud, has been abstracted with Nitro, which is one of the key differentiators of what we do in EC2.
Cool. And that also means that you get more of the resources that you pay for, right? Because all of the virtualization and stuff, that's not free, but we've offloaded that.
We've offloaded that, yeah. So customers don't pay a tax. They don't see any of the overhead of what we do in the virtualization side of the compute.
Cool. Concurrent customer, this is a question from AWS Alligator. I like that name. Can current customers using EC2 instances on Intel switch to EC2 using AMD EPYC? Yeah, it's pretty straightforward, especially with the app compatibility that you mentioned.
Absolutely. I think the flexibility between the two is there. I would say customers using Intel can go to AMD, and customers can go to from AMD to Intel. And I think the ability to switch back and forth is what makes this so interesting, right? Because you can say, like, let me start with AMD, save 10%, then I need a little more compute, you jump to Intel. And vice versa. Maybe you're using Intel today, and you're like, my workload ends up waiting for a transaction from a database, so it becomes a lot more I/O bound. You could easily just say, hey, maybe an AMD one might be better for this workload, right? And that switch becomes very compatible both ways. And that's what Nitro, once again, enables, because then you have the same driver set, the same hypervisor experience. It ends up being a very easy kind of transition.
Cool.
Nice. I had a quick question. So what's been the reception to these EC2 instances so far using AMD?
The reception's been great. I think lower price point doesn't hurt. I think customers get very excited. 10% ends up being a pretty significant discount for current instance types. But we have thousands of customers using these. We launched the first AMD EPYC ones back in November of last year. Okay. And then we've deployed them initially to 5 regions, and now we've expanded to 8 regions. Yeah. So we have a full global footprint, and customers have really bought into the cost savings and then the compatibility, right? I think we made it really easy. I did all the hard work for you guys and made it really easy for you to say, hey, look, I just need so many vCPUs. I only need so much memory. You can kind of switch and decide without having to okay, this one has 10, the AMD one has 10, the Intel one has 19, and how do I balance all that complexity has been taken away. So it's been very well received by customers. The cost savings, the compatibility, and then the familiarity on the sizes.
Nice. Do we have any more AMD instances planned for the future?
Yeah, I think it's really, I kind of challenge the dev community on this. I want to build what customers tells us is important. 90 to 95% of what we build in AWS as a whole, not just EC2, comes from what customers tell us what matters, right? Yeah. So I think I've seen initial traction has been very strong in our core families with AMD EPYC, and I think I have a lot of cool ideas for where it can go next, but I would love to see customers tell us, hey, this is where I'd want to see it. So please give us that feedback and show us that this is important to you, and I think there's plenty of opportunity to expand AMD within our portfolio.
Awesome.
All right, well, we are just about out of time. I've got one more question I want to ask, though.
Sure.
What is the maximum amount of memory that I can get on an EC2 instance?
From an EC2 instance perspective, you can actually get 12 terabytes of memory on our high memory instance types. But with AMD EPYC, you can get up to 768 gigabytes of memory.
That still sounds like enough.
Yeah. It sounds like, it's a lot. It's a lot.
Wow, okay, great. Well, Alex, thank you so much. It's been really cool to learn more about EC2 and really excited for the new AMD EPYC-based instances that we've got. Thanks so much for joining. Kunal, thank you as always for being here.
Guys.
Great. Awesome to be here. Thank you.